Welcome back, and today I'm going to show you some concept behind threading. So what is a thread? Actually, let's just imagine we're going to start with our computer. Okay, and in order for this computer to run, you need to have two main components, which is the processor, next one is the memory. And within this computer, you are able to run multiple applications. Okay, multiple applications. Let's just give an example. Inside this computer, I'm running Paintbrush is one of them, and I'm running another one is text edit, and I might be running Google Chrome as well. This one. So at the same time, my computer is running multiple applications. Okay, and that one is called inside my computer is called multiprocessing or multitasking. This one is processing or multitasking. Okay, multiprocessing, because inside this computer I have two applications is running, and what is why do I call it process? Actually, a running application is called a process. Okay, and within one computer here, let's say within one application here, let's say Google Chrome, I may have multiple Google Chrome. I may have multiple threads running together. I may have multiple threads running together to establish multiple tasks inside this applications. Okay, I may have multiple threads running together. Okay, threads within one application. Okay, not within a computer we have many applications. Within one application or within this one running application or one process, I may have multiple threads running at the same time, and they are executing multiple tasks at the same time, and each of your application is having its own processor. Okay, time slot, and it has its own section of memories in order to work. This one as well, processor and memory section to work. And each of the threads here also have its own resources to execute, which is processor and memory as well. Okay, and memory as well in order to work. Okay, and let's just demonstrate this one by showing what's going on inside our computer. Okay, you'll see from here. Okay, I'm showing activity monitor inside my computer, and you see inside this computer, in order to work, you need the CPU and the memory for your applications. And let's just look at memory resources, and you'll see inside my computer I have many processes which are running. And what are the processes? The processes are the running applications. Okay, let's give an example. Our computer is running Google Chrome's. Okay, and Google Chrome is here. Okay, Google Chrome, and at the same time it's running other tasks like PowerPoint, NetBeans, and text edits as well. What is text edit? Text edits here. Okay, and especially within this text edit, there are four tasks that I'm working at the same time within this text edit. Okay, within this text edit, there are four threads running at the same time. And if you're looking at Google Chrome, okay, if you're looking at Google Chrome's, where's Chrome? Okay, Google Chrome's, and you'll see from here there are now even 45 threads which are running inside this computer, and they are sharing CPU as well as memory inside this computer. Okay, memory as well as CPU as well as they have their own CPU amount as well as memory amount. Okay. So let's just give another formal definition. This one is the idea about what the thread is. So let's just give another formal definition. So inside a computer, there are many applications, many running applications, and they are called multiprocessing. Okay, multiprocessing. Okay, so this one is multiprocessing, and within one applications or one process, which means a running application. Okay, within one running application, within this one running applications, okay, within this one running application, there are multiple tasks are being executed at the same time. And what that means, executed at the same time, and here and each of the tasks is executed by a thread, and the thread has its own, okay, has its own running resources. Let's say memory and processor time. Okay, and this one is called a thread. So the formal definition is what is a thread? A thread is a smallest unit of executable code. It is smallest unit of executable code because it has its own resources for running. Okay, it has its own running resources. Of course, this one is to establish a particular task. Talking about to establish a particular task, it's similar to actually the definition of a function. Or just to say it's simple, a thread is to run a function. Mean a function is to is a block of codes to establish a particular task. Okay, so you can have the arguments here. So how do you target smallest units of executable code when inside the thread it is a function? Okay, and inside the function there are many lines of codes, but let's just imagine that this one is smallest unit of executable code because it has its own resources for running. It has its own resources for running. You don't have your own resources for running, like processor time or memory for single one statements or two statements to execute. Okay, if it is not separated or is not assigned to a thread. So a process has its own resources to run, or application has its own resources to run. And inside application, you have threads, but inside threads, you don't have anything else, which is running in parallel and having its own resources to run. And that's why it's called smallest units of executable codes. Okay, so why do you need threads? Why threading? Why threads? Later on, when you study in detail, you'll know more about threading. But threads means you can run things, or you can do things, or establish tasks at the same time. Okay, at the same time. And so this one is going to reduce idle times. Let's just give an example about what does it mean reduce idle time. Let's say we have task number 1 and the task number 2 to be executed. Okay, and when task number 1 is executed first, and somehow it needs to stop and wait for resources from hard disk, let's say. So it need to read resources from hard disk, or it need to read resources from it need to read resources for it needs to read resources from network, let's say. Okay, network. Okay, so on and so forth. And if you execute it sequentially, one by one, then why task 1 is waiting for its resources, and task 2 is still need to need to wait for task 1. Okay, to complete first before task 2 is running, and this one is the processor's time is going to be idle. So if you have multi-threading and you can run the two threads in the threading manner, then if task 1 is executed first, then when it needs resources, then it's going to wait. And if task 1 is wait, then at the same time now task 2 going to be executed. Okay, without waiting for task 1. So you can make use of the processor time, so you can reduce the memory processor time. That one is, let's give an example. In this one, it had two threads. The first thread is it's going to read some resources from memory. This one is task 1. Okay, and read some resources from memory. This one is gonna wait until it go to the not memory, hard disk. Okay, hard disk take some file, and it's going to get back to the threads, and threads going to continue, then finish. Okay, and then after that you run thread 1. After that you run thread 1. So this one is going to take some times. But if you run two threads at the same time, you have thread 1 is running like this, and when it's waiting for the memory, okay, when it's waiting for the memory, and you can start running thread 2. start running thread 2, and when you complete thread 2, it is the time this one has the resources back as well, then it's going to continue to run. So you save a lot of more time, or you can make use of your processor time. It has a lot of other advantages when you use thread. Let's say it's going to increase responsiveness. So you don't have to wait for a long task. Let's say you have some long task. Okay, if you have some long task in order to complete, and while waiting for that long task to complete, another task have to completely wait. So if you could do different tasks together, even you haven't completed the task, but you still can return to the user some of the partially done work, so that user going to have some response directly from your system. Let's say this one is not a website. Okay, a large website is not very responsive if you don't have threading. Okay, if you don't have threading. So talking of threading, there is one more concept that I would like to explain. Threads is smallest units of executable tasks is to execute several tasks at the same time. Okay, at the same times. When we say it is at the same time, it's actually relatively at the same times. So let's just compare the difference between executing at the same time and sequential. Okay. And sequential execution. Let's say I have two tasks. The first task is going to be executed. This one is task number 1. And the computer is going to wait for task number 1 to complete before executing task number 2. This one is called sequential execution. Okay. And threading is executed at the same time, but it doesn't mean that you can run tasks thread 1 and you can run thread number 2 at the same time absolutely this way, except some advanced technologies with multiple cores, processors, so on and so forth. But normally, usually, it is not executing at the same time this way, but it is going to happen this way. You execute task number 1 for sometimes, okay, you're going to occupy the memory as well. You occupy the processor for sometimes. Then you're going to wait. Okay, wait for the you're gonna give your turn slots to the thread number 2. Okay, thread number 2. Then thread number 2 is going to execute for sometimes. Okay, going to execute for sometimes. Then thread number 1 is going to execute. Similarly, after that, it's gonna go for thread number 3, 2, then thread number 1, then thread number 2. Up until this one finish, this one going to finish as well. Okay, so what does that means here? They are not absolutely running together, but they just alternatively take turns to use their memory as well as the processor. So we're going to take some time slot division there. Okay, time slot division there. So if this one is in charge, this one is either. It's gonna wait, and this one, if this one is this state is called running state. If it is executed, it's called running for let's say for this slot, for this time slots. Okay, for this time slot. And this one is taking the memory. It's called running state. It is in running state. Okay, it is running states. Okay, and for this one, it's called runnable state only. It is runnable but waiting. Okay, this one is runnable. Okay, runnable. About trading, we're going to states of trades. We're going to explain about this one later. Okay. About other details, how to create the trades, how to manage the states of the trades, how to how to work with trade methods. We're going to talk about them specifically when I show you some demonstration code. Okay. See you later.